Hey there, good evening everybody, and once again, welcome back to the channel. This video, I want to show you or teach you how you guys can get started with EMR serverless, use Delta Streamer on EMR serverless, and also in addition, we're gonna use Xtable, which allows you to interoperate between Hoodie, Delta, and Iceberg. All of that is in this video, so without wasting any further time, let's get straight into action. Alright, so the first step of the project is we need an EMR serverless cluster. So let's go ahead and spin up. I'm on my AWS management console and let's click on this orange beautiful button which says create application. And let's give it a name, big data, big data Spark cluster. Let's keep the type as Spark. Let's use the latest EMR 7.0.0. Architecture, let's leave it to x86 and everything else to default, and let's click on create and start application. As you can see, I have my EMR serverless cluster over here and now it's in the starting state. Alright, so the step 2 of the project is now you need a sample dataset and the jar file. So we are gonna upload these jar file on S3. Let's take a look at the process. Here I'm using this bucket. What you wanna do is create a folder called test. Inside the folder, upload the sample Parquet file, which should be available. The links to the Parquet file is available on my GitHub section, okay? This is a sample Parquet file. If you click here, action, and if you try to query H3 select, and if we just quickly do, just want to show you how the data looks like. So to run SQL, again, this is how the data looks like, right? You have an operation, you have some replication timestamp, invoice ID, item ID, category, price, quantity, order date, destination, state, shipping type, and referral. So again, bunch of some data so we can learn how to use Delta Streamer with Xtable and interoperate between all the three lakehouse format. So that's that. So make sure you have uploaded the sample dataset inside the test folder, okay? Now create a folder called jar in the S3 bucket, and we need two jar files over here, okay? The first jar file is hoodie extension 0.1.0 snapshot bundle jar. This jar file allows us to interoperate between Hoodie, Iceberg, and Delta Lake. So after each commit, it will build the metadata for Iceberg and Delta, right? And then we need the Hoodie Java client 0.14.0 jar. So these are the two jar files we need for the project. So please download these two sample dataset and the jar file and kindly upload them into S3. Now let's take a look at the third part, which is the Delta Streamer and the Xtable code. Let's learn how to submit the job, okay? Alright, so now the next step is we need to generate the IAM role, and then we're gonna copy the EMR serverless application ID so we can now submit jobs, right? Let me show you the process. So now let me share my screen. Again, we created this cluster, right? Called Big Data Spark cluster, right? Click on that. Again, it's in the started state. Copy this application ID, okay? Now we need an IAM role as well. So copy this in Notepad. And now the best way to generate an IAM role is this is how I do it, right? Simple. So come here to submit job, and here come to runtime role, and then click on create new role. And this will open up a modal. And now what you want to do is either select all buckets in this account, or you can select specific bucket, and then it's gonna create the IAM role for you. Once the IAM role is created, please copy the ARN. I have already generated an IAM role. Here you can see I have copy pasted the role over here. Again, now in the project directory, there is a file called env, and now we need to edit the environment variable. So put your application ID over here, put your execution ARN, put your AWS access, secret, and region. Now let's take a look at the Delta Streamer code. So let's review the Delta Streamer code, which we're gonna submit on the EMR serverless. I wrote a simple Lambda function, which will submit the job. Over here, we're defining imports, so there's nothing that I need to explain. I load all the environment variable, such as access, secret, and region. Then I create a client object over here that is using Boto3, okay? And then here I define all my settings, right? Hoodie related settings, such as my record key, my pre-com key, my partition path, how I want to partition it, my dedupe key, right? My source where I want to ingest the data. So we uploaded a test Parquet file inside the test folder, right? the output, right, where you want to build your hoodie transaction. They're like application ID, the EMR application ID will go here. The EMR ARN, the role to submit the job will probably go here. Now this is the settings that I probably want to walk you over. So the first one is basically conf spark.jars, as you can see, user slash lib slash hoodie utility bundle jar. So inside EMR, you will see this particular directory, user lib hoodie, and inside that, this jar is gonna be there. Again, for some reason, if you wanna use your own, compiled bundle jar, you can also do that. So just wanted to make sure that I point out that right now we are using the one that AWS has, right? So inside user lib hoodie, this particular jar is there. And then we are gonna give two jar paths separated by comma. The one is hoodie extension -0.1.0 snapshot bundle jar. This extension will allow Delta Streamer to perform the translation of the metadata after every single commit. And the next one is basically the hoodie Java client jar, okay? And then over here, we define the class as hoodie Delta Streamer, as you can see my cursor, right? And then here we just have simple, Delta Streamer job, right? As you can see, we are ingesting data from the Parquet. So the class is set to Parquet DFS source, right? We provide the operation as upsert, the table type as copy on write, and this one parameter that we need to add, which is -sync -tool -classes. The value should be set to io.onetable.hoodie.sync.onetable sync tool, and then on the bottom you will provide a configuration which is hoodie.onetable.format.to.sync. The value is set to iceberg. Either it could be delta comma iceberg or iceberg, whichever metadata you want to build after every single commit. You just need to provide the value over here. And that's about it. And then we simply submit the job to the EMR. So now I think, what would make sense is, to actually submit this job and show you everything in action. So I'll basically right click on this Python file and then basically run this particular Python file. So hopefully, as you can see, I got a response, which means the job has been submitted to the EMR cluster. So if I now refresh here, as you can see, this one over here is in the pending state. Hopefully you can see that, right? So yeah, all the arguments are passed, and now let's wait for this job to complete. And once this job is complete, I'll show you the output directory on S3. So right now the job is in the pending state. Hopefully the state should soon change from pending to schedule and from schedule to running. So I'm gonna pause the video right here. As you can see now, the job status has changed to running. So again, I'm gonna pause the video again and then resume once hopefully the job is in the complete state. The job is now finally complete, as you can see. All right, so now what we can do is we can head over to S3, and I'm gonna refresh my directory over here, and I should see, yep, test cases, perfect. And I see all my partitions. Inside each partition, I have my Parquet and the metadata. Perfect. Okay. Let's see if Xtable has built the metadata for iceberg. So I can probably look for a folder called metadata, and here you can see. And here you can see, one table which was now named to Xtable has now built the metadata for iceberg. So this lab, what you have learned is, let me summarize, hopefully this makes sense. Step one, create a EMR Spark cluster, EMR version 7.0.0. Step two, download the jar file, upload the jar file on a directory called jar. Step 3, download the test Parquet file, upload the test Parquet file into a folder test. Step 4, download the source code, change the environment variable, such as your AWS access, secret, and region, and then change your application ID for your EMR cluster, and then try submitting the job and see everything in action. I hope this video was useful, and I hope this video taught you how to use Delta Streamer with Xtable on EMR serverless. If you have any further questions, please do post your question in the comment window, and I can try my level best to answer those questions. And if I do not know, of course, I'll ask someone or I'll learn myself and then try to get back to you. With that being said, thank you so much for watching the video, and I will be seeing you in the next video. Thank you.